Right. Hi, my name is Alberto. I'm going to talk to you about the Fable Compiler, which is kind of brings together F# and JavaScript in a very interesting way. To have a clear view of what is Fable, we can compare this with Reason, for example. Reason is another compiler that targets OCaml and translates that to JavaScript. So here we have a kind of a category theory diagram. On this node we have OCaml or F#, and here we can go two routes. One is transforming the AST, the typed AST of F# to some other AST, in this case the Babel AST, that then finally gets translated to some JavaScript AST and gets preprinted. The other route that ReasonML takes is to use the OCaml compiler and to go all the way and compile to bytecode, and then through some intermediate language translate that to a JavaScript abstract syntax tree that then gets translated to another final JS AST, which gets preprinted to JavaScript. So here's an example of the Reason approach taken from the paper about JS OCaml. Here we can see the bytecode instructions, and then there's some intermediate code that gets lifted to some JavaScript AST. In the case of the Fable compiler, here we have two compilers, and the F# compiler translates to a type AST that can then produces .NET intermediate language, and then Babel takes some version of JavaScript, translated to an intermediate Babel AST, and then can output JavaScript for all the different flavors. So the great idea of Fable compiler is to reuse these two pipes. So we go from F# to a typed AST that gets translated to an intermediate Fable AST. Then we go to a JavaScript AST, and then finally to JavaScript. This has a few advantages. We can do optimizations, and we can have, more importantly, a plugin system that, in my opinion, is the best foreign function interface that you can have. An example of an optimization is some piece of F# code. We have a list, and we do mapping. We take some elements, we filter them, and then finally transform to an array. If we do a naive translation, we could end up with something like this, which up here is importing the Fable library, and then after that it's kind of a continuation passing style with all these big functions, but really all the work gets done by the library, like that int32array.from, or that call to sequence.filter or sequence.take. By taking advantage of the Fable AST, we can the Fable compiler produces readable and more optimized code, where we can see that there's an import to the Fable call library, and then it's just making exactly the same calls that we had before, but this time there's a lot of saving on the passing around between functions. Another feature that, in my opinion, is the best is the plugin system. So the plugin system, thanks to that intermediate AST that we have for Fable, allows us to define backend replacements for .NET libraries, or for libraries that we can define ourselves. In this case, in the Fable website, they give the example of the random function, and we could potentially define two backends for the random function. One where we use the node JS random function if you're working on the back end, or we can call the normal JavaScript random function if you're working on the front end. So there are a few things that you need to do. For example, you need to define this apply info, which is the AST that will be required by the F# compiler during compilation. We will need to do some things like, in this case, the random library is implemented as a class, so we need to define some constructor. And in this case, it's just a dummy constructor, because really, when we come down to emitting the code, we are just producing, in this case, the front-end random function to JavaScript. So one thing that it is defined as an FFI in F# is the Elmish library, and this uses the model view update architecture, where the view usually the user will trigger an action that sends an message to an update function, and then the update function just goes and triggers an action on the model, and then the model will go and trigger render on the view. So there are a few concepts that we need to describe the Elm architecture. Model is a snapshot of the application state defined as an immutable data structure. A message is an event representing a change in the state of your application, and there's an init function that produces the initial state of your application. We need an update function, there's a pure function that produces a new state, a view that renders the UI, and the program, which is the opaque data structure that combines all the elements plus a set state function to produce a view from the model. So in the Fable architecture, we have what we know as the dispatch loop, where the program starts and renders a view. Then the view, if prompted by the user, can trigger a message. Then the program sends the message with the current state to our update code, and then the update code returns an updated state and command, and finally the program renders the view. So here I made a simple example of Elmish component, which is just a very simple state machine that goes lights off, lights on. So if the lights are off, we get that view, and if the lights are on, we get Fable neon lights. The model to describe this transition is very simple. We have two states, on and off, and there's a message flip switch. The way we can define this in F# is very simple and elegant. So we define a module called lights, and we define types that define our model. So there's a type switch state, which can be on or off. The type of our model is switch state, and we have a message that is flip switch. The init function is very simple. It returns a pair of the model and some command, which is a list of messages. And when we initialize our component, we said that it's going to be off and there are no messages to be processed. We code a very simple transition function, which is our state machine. That is when the switcher is on and we flip the switch, it goes to off, and when it's off, it goes to on. And then we code an update function that receives a message and a model, and it's very simple. When they get the message that the switch has been flipped, then we just apply the transition function to the model. A view, the view is again very simple. We just have some functions that act as HTML tags, and we just have this string that says Fable, and when the model changes, it gets rendered differently because there's a screen style function that affects the model. And then if you want to learn more, you can go to this address, github.com, Javaga Fable Workshop. And over there I have more exercises that I hope you find interesting.